Today we're continuing to talk about chemical reactions, so we're able to predict the products of any given reaction. Our success criteria for today is being able to describe combustion reactions involving carbon compounds. So combustion reactions are a bit different than the other reactions we've talked about. Carbon specifically gets its own field of chemistry called organic chemistry. There are millions of different compounds that are considered organic, and there's some that also contain carbon that aren't, like carbon monoxide and carbon dioxide. Carbon gets its own field because it's so flexible. It is able to bond in many different ways, which means it can build extraordinarily complex compounds. It's called organic chemistry because it was originally thought that carbon was only really found, with a few exceptions, in living organisms. We now know that that's not the case, but it still retains the name of organic. A hydrocarbon is an organic compound that's just made up of carbon and hydrogen. Things like methane, which is CH4, ethane and propane, C2H6 and C3H8. These are hydrocarbons. They're made of carbon and hydrogen. And hydrocarbons are really useful for us because when they react with oxygen, they burn. And that liberates lots of energy out of them in an exothermic reaction. We use these combustions all the time to create heat, to create electricity, and then transform electricity into different forms. So our entire society runs off of hydrocarbon combustion. Hydrocarbon combustion actually follows a really simple pattern. There's always a hydrocarbon reacting with oxygen, and it always produces water vapor, which, remember, is water as a gas, and carbon dioxide. How that balances out will look different for each different type of hydrocarbon, but they all follow that same pattern. You have a hydrocarbon reacting with oxygen, and that will produce carbon dioxide and water vapor. We call this complete combustion, when you're liberating as much energy as possible out of the hydrocarbon. But we can also have something called incomplete combustion as well. And even though we often talk about complete combustion in chemistry, in reality, it's incomplete combustion that happens most of the time. Incomplete combustion can produce some additional products, things like carbon monoxide. It can also produce pure carbon as soot, and it may or may not produce carbon dioxide. Anytime you see smoke as part of a fire, it's incomplete combustion. That soot, pure carbon breaking off, instead of being converted into carbon dioxide. Okay, so what determines if it's complete or incomplete combustion? It's the amount of oxygen that's present. Incomplete combustion, you have lots of oxygen present. There's a good solid supply all of the time, so it's able to react fully, which releases the most energy. But incomplete combustion occurs when the oxygen supply isn't so good. So you get carbon monoxide, which has fewer oxygens produced, or sometimes you get soot, pure carbon, just getting broken off of the hydrocarbon. You will only ever have to balance complete combustion. You do not have to balance incomplete combustion, and in fact it's extremely difficult to balance incomplete combustion because it's highly dependent on the conditions. So you need to know that incomplete combustion exists, but you do not have to worry about balancing it.